And the next speaker on Chapter 34 is SAFDAR Khan. I think you've been to every class here on campus. A couple of others have been too, but Muhammad and I'm suddenly blank. I can't remember your name. Yeah, Ahmed, right? Okay, we're going to have SAFDAR come up here, and need to first let everybody get a good look at him. You married?
No.
You're good looking. I just thought if there's anybody. No, I'm just kidding. I don't want to embarrass you. I guess I already have. You're from
India.
Mumbai. Okay. And I guess you probably know how to operate this stuff by now. The most reliable way, just go down or up or right, left. Don't use the right button on this thing because you can point with it, but you can't back up with it. You can go forward on this one, but you can't go backward on that one. So I guess you need a mic. Leave that. You can put that in your belt or whatever. I guess the other way. You don't plan to use the overhead camera, do you?
No, no.
Okay. You're all set. Go for it. I'll push PC. Yeah. You're set. Good.
Good afternoon, everyone. My name is SAFDAR Saeed Khan, and I'll present you Chapter 34, Network Maintenance and Testing. This is the overview of this chapter. In the first place, we'll discuss Network Operation Plan. What is Network Operation Plan? We'll define Network Operation Plan. After that, we'll look at troubleshooting methods. What are the different troubleshooting methods? Then we'll have a look at test equipment standards, the test equipment standards that are used in the company these days. After that, we'll discuss two important testing systems. The first would be host-based testing, and the second would be outbound testing system. Then after that, we'll look into equipment selection consideration. This is a very critical point in this chapter, and we'll look this point in detail. And finally, we'll look at protocol analyzers and analog test circuits. Network Operation Plan. What is Network Operation Plan? Let's define it. Network Operation Plan is a plan that discusses procedure that network group uses to provide superior service and control cost. I would like to make a point over here. Before 2009, there were only big companies, those who used to have network operation plan. But after the recession, there has been even smaller companies, those who have network operation plan. The importance of network operation plan is the plan is used to reduce cost and quickly debug the network. So if there is something going on in the network, you can just you know the entire thing and you can quickly rectify the error. And the second important thing is, while you are developing a network operation plan, it's very critical to develop a testing plan simultaneously. The third point is defining testing techniques in a network operation plan. You need to define the testing techniques you will be using in a network operation plan. Now, I would like to discuss some terminologies related to Chapter 34. And first one would be demarcation point, also called as demarc. Now, what is a demarc? Let's define it. The demarcation point is the point at which a telephone company network ends and connects with the wiring at the customer premise. The figure over here shows two demarcation points. The one on the right hand side is the modern demarcation point, and the one on the left hand side is an old demarcation point. A splitter for a DSL modem has been plugged into the modern demarcation point, as you can see over here. This figure is a demarcation point. It's taken from Bell, Canada. Now let's discuss something about network testing. So you can see over here a network testing and maintenance engineer testing a network site. There are 4 different ways. Actually, there are a lot of ways of testing a network, but I've discussed 4 of them. The first one is connect a butt inset to the demarcation point to find out whether a dial tone is present or not. So if a dial tone is present, you can know that the network is fine. But if there's something wrong in the dial tone, or if you're not getting a dial tone, that means that there's something wrong in the network, or the network has failed. The second is check for loose power. The third one is connect a RS-232 cord in an operative terminal. You can make a note over here that RS stands for recommended standard. And the fourth and the last one is connect a modern demarcation point tester. You can see it's using over here. Network maintenance strategy. Now, a lot of telecom companies use network maintenance strategies these days. There are several network maintenance strategies that are employed. So let's discuss a few of them. First is no self-maintenance. All trouble is referred to a contractor. That means that the company does not do any kind of self-maintenance on their own, and all the trouble or all the network maintenance is done by a contractor or another company. The second one is limited self-maintenance. That means that the company does certain amount or a limited amount of self-maintenance on their own, and the rest of it is given to a contractor. The third one is, this one is generally used in most of the companies, which is self-maintenance for trouble. Call a contractor when your effort fails. It means that the company does self-maintenance on their own. They try a lot of self-maintenance, they do a lot of debugging, and if they are unable to troubleshoot the error, they call a contractor. The third one is full self-maintenance. The fourth one is full self-maintenance on one class of equipment, but limited or no maintenance on the other class of equipment. That means that on certain equipment, the company does self-maintenance, and for the rest of the equipment, there's a contractor. And finally, the last one is full self-maintenance. It means that the company does all the network maintenance on their own. Okay, let's discuss something about network troubleshooters. Network troubleshooters are the people, those who debug the network or those who troubleshoot the network. These are very important people in networking companies. Troubleshooters have a highly developed and experienced technique. All troubleshooters generally use the same approach, but they usually don't agree with this statement. But the fact is that all troubleshooters generally use the same approach. Troubleshooters always use inductive reasoning techniques. It means that troubleshooters use inductive logic. They generally troubleshoot using reasoning from detailed facts. Okay, ways of troubleshooting when a network fails. Now, these are the 4 general methods of reporting a network failure. The first one would be alarm. So, when a network fails, the alarm gets activated and the operator knows that there's something wrong in the network or the network has failed. So, he calls the network troubleshooters for rectifying the error. The second one is status report. It is a report summarizing a situation in a network. So, let's say there is something wrong in the network, and the status report will show that there is a deviation from the normal operation. So, that's how you'll come to know that there is something wrong. The third one is user report. User reports are generally the first indication of problems that do not involve hard faults. So, if there's something wrong in the network, the user, those who are using that network, will realize that there's something wrong, and they'll call the company for that. And this is how the company will know that there's a network failure. And fourth and the last one is online status monitoring result. So over here, whenever there's a network failure, it can be seen online. Okay. Typical process for troubleshooting. This is a typical process for troubleshooting over here. This is a process for troubleshooting which is used by network troubleshooters. The first one is, so what happens over here is, when there's a network failure, there is an alert system like an alarm or a report which indicates that there is a network failure. So the network troubleshooters come and they start troubleshooting, and here are the steps of troubleshooting. First, they'll define the problem, what the problem is and what the problem is not. After that, they'll develop hypothesis. So developing hypothesis use inductive reasoning or inductive logic. The troubleshooter is in a good position to develop theories of what is causing the problem, and these are based on the experience they have. After that, there's a very important point called isolate the cause. So the troubleshooters must isolate the cause, and they use four techniques for that. That can be substitution, testing, sectionizing or bifurcation, and fourth and last one is pure reasoning. After that, the network troubleshooters will correct the problem, which is primarily the purpose of this flowchart, and then they'll verify the results. Verify with the normal operating condition as to whether the system is working fine or not. In each step, we need system documentation. System documentation is very important, and in the four phases, we need testing. Okay. This is a network diagram to illustrate troubleshooting process. So here PBX in city A is connected via T1 lines and T1 multiplexer to T1 multiplexer in city B. You can see over here this connection. And city B PBX is connected to T1 multiplexer via analog tie lines. Half of the T1 is used to connect LAN in the two cities. In city B, the PBX is in one building and the LAN is in another building. So in such a huge network, if there is a network failure, it's very difficult to debug the network or rectify the error until and unless you have something called as partial troubleshooting diagram. This is a very important point in this chapter, and we'll discuss what is partial troubleshooting diagram. Partial troubleshooting diagram is nothing but a flowchart. Now let's say there is something going wrong in the users in city B can't log on server in city A. So you'll go to the next decision box and you'll ask a question. This is basically a logical question asking, can any station log on? So depending on the answers, we'll move forward in this flowchart. So let's say the answer is yes. So we move on to this next logical question, that is the server down or not? So let's say over here that the server is down. So you come to this box and you call the server technician to rectify the error. So depending upon the answers of your logical question, you will reach to a certain conclusion, and that's where you will find out what the problem is. And that's why partial troubleshooting diagram is very critical as far as network troubleshooting is concerned. Okay. How can a company take corrective actions? Corrective actions can be taken in one or a combination of the following methods. The first one is refer it to another responsible group, for example the local exchange carrier. The second one is change the defective equipment or card. The third one is correct wiring defects. The fourth one is substitute known good equipment. That's how you'll be able to rectify the error. And then patch to a known good circuit or equipment, and finally redesign to remove the cause of overload. And that's how you can correct a network troubleshooting problem. Now test equipment standards. Test equipment standards are very important as far as selection of your equipment is concerned for network troubleshooting. And you need to know all these critical characteristics of test equipment standard. The first one is portability, that whether the equipment is portable or not, so that you can go to different places and debug. The second one is whether it is programmable or not, and up to what degree it is programmable or not. The third one is software or protocol interface. Data test equipment is usually compatible only with specific protocols and must be chosen to support the ones your network uses. So it is very important while you are selecting an equipment to take this point into consideration. Then comes functionality and ease of use, whether your equipment is single purpose or multi-purpose, and how easy it is to use that equipment. And the last one is vendor independence. One of the major hazards in constructing a telecommunication testing system today is too much independence on a single vendor. So you must be selective, you must look at various options you have and then determine as to what vendor you have to go for. Modem loopback testing to determine defective circuit element. This is one technique by which you can determine the defective circuit element. So over here you can see there's a computer, then there's a modem, and after that there's a transmission line, then again there's a modem and there's a computer. So over here you can see that when you are testing a network, local digital loopback is mentioned over here. This is because the data while transmitting from computer to modem is in digital form. That's why it is local digital loopback. After that you will see a modem over here and it says local analog loopback. This is because the data is converted from digital to analog for transmission purpose and it says local analog loopback. That's how you do modem loopback testing. So by progressive looping a circuit, it is possible to detect defective modems at near and far ends of the circuit. Defective circuits and defective terminals or modem to terminal connections can be detected using this technique. Now, as I said, we will discuss two techniques, that is host-based testing system and outboard testing system in detail. So let's first take host-based testing system into consideration. Now, data communication networks are tested by distributing testing functions at each individual circuit termination point or by a host-based system. So these two systems, they both have their own merits and demerits. So depending upon what's likely to be used in your company, you need to determine which one to be selected for your purpose. Host-based test systems are often highly effective if the same vendor supplies all the network equipments. The disadvantage of host-based system is they do not work with other vendors. So you need to take this point into consideration. Now the other is outboard testing system. Here we use standalone equipment. In these testing systems, test access and switching points are connected to switching equipment that brings them out to spare equipment, testing equipment and responders. External circuits, often dial-ups, are used to connect to the circuit under test. So these are the points in outboard testing system which differ from host-based testing system. Now protocol analyzer. Protocol analyzer have been very much in demand in recent years. It was in demand, now it has been more popular. So protocol analyzers are a family of equipment that can capture traffic on transmission medium, trace it and display the content of a PDU to allow an experienced operator to diagnose the problem. The major functions performed by data analyzers are device emulation. Device emulation means that analyzer can be substituted for any device on the network. Next is trapping. Trapping means that the analyzers can be programmed to look for a particular data pattern and trap one or more blocks preceding and following. The third one is performance measurement. The protocol analyzer can be used for performance check. there can be different types of performance measurement like response time, block error, line utilization. The fourth one is LED status. Analyzers can show the status of control LEDs on an interface and the transition between states. Now, selection consideration for protocol analyzers. So, these are certain selection considerations that a network testing company must take into consideration while selecting a particular protocol analyzer. The first one is, does the system runs on a laptop PC? How many links it can monitor? What is the maximum traffic load it can monitor? Can you export data to external device? So, while you are exporting data to external device, you must know the file format for that. Can the system translate the traffic? That means that can the system convert information from hexa to ASCII? Can the system generate traffic to stress test the network? And finally, can the system capture and analyze network performance? Analog test circuits. This is one of the final points we will discuss in this chapter. Analog test circuits are made on both voice and data circuits. Analog testing is diminishing in importance as analog circuits give way to digital, but some testing still may be required using analog test circuits. So, some of the testing that is still done by analog circuit test is gain frequency response, steady state noise testing, impulsive noise, phase glitter testing, etc. Finally, the conclusion of the chapter. Network maintenance is necessary because of two reasons. The first one is speed of service restored, and the second one is economy or cost cutting. The second point is the maintenance strategy of most companies tends to grow and evolve and are related to the company history. Final one, testing and maintenance procedure should however be a part of every network operation plan. And I would like to share a very good thought, that is, one thing is for certain, if you clear the troubleshooting without understanding the problem, it is not troubleshooting, it is just good luck. These are the references that I have used. Thank you so much for your patience. Have a nice day.
Back. That was an excellent presentation, and I particularly appreciated the fact that you had a lot of references, not just the book, and you did good research and also made some very effective slides from the text, which were non-obvious. I want to spend just a couple of minutes. We're going to have another presentation on network. This